Hello students, today I am going to start the paper number 3rd of TYBSc is Organic Chemistry. According to revised syllabus in your semester 2nd examination, there are only 3 chapters to you. First is carbanion and their reaction, second one is rearrangement, and last one is the spectroscopic techniques. So we are going to discuss our first chapter is carbanion and their reactions. So first of all, what is a carbanion? In the introductory part, what is a carbanion? Carbanion is nothing but it is the negatively charged carbon, means carbon containing the negative charge is the carbanion. The carbanion has sp3 hybridization. In that there are out of 4 sp3 hybrid orbitals, one orbital carries the lone pair of electron. So due to this hybridization, the carbanion has tetrahedral geometry. So basically how carbanion is formed, when any CH bond or any bond, here is the hydrogen is there or one of the atom or group is here, when this bond is cleave, and after cleaving, if the two bonding electrons left on the carbon, after this dissociation the carbon carries the negative charge. So this way carbanion is formed. So this is the one of the reason. Second thing is, suppose we consider another example. Here is a benzaldehyde. Okay, so benzaldehyde has CH3 group is here. Due to presence of carbonyl group, the hydrogen which is present on alpha carbon to the carbonyl group having the acidic in nature, because due to minus R effect of carbonyl group, there is a electrons are delocalized this way. Due to this, there is a polarization between the CH bond, and due to this polarization, any base, if base is here, base will abstract this proton, acidic protons, because these protons are acidic in nature. When proton is abstract this proton, when base is abstract this proton, these two bonding electrons are goes on carbon, left on the carbon. So there is a formation of CH2 negative C double bond OH. Again we call this is the carbanion. Carbanion will stabilized by, again second factor is when carbanion is formed, it should be stabilized. How they stabilize? So number of factors are responsible for the stabilization of carbanion. So this negative charge will stabilize by the minus R effect of carbonyl group. So when carbanion is stabilized, it is readily formed. If not, it is not easily formed. So this way there is a formation of carbanion. Okay, so any CH bond if behave as an acid, any CH bond is behave as acid. Here is a substituent, R is the substituent. Due to presence of substituent, if the hydrogen is acidic in nature, it will lost minus H plus due by the base, and here formation of negatively charged species is the carbanion. It is the carbanion. So this way there is a formation of carbanion. Okay. Next, in next point we are going to discuss in by using which methods the carbanion is formed. There are number of methods. So here we are going to discuss carbanion formation. Carbanion formation means how carbanion is formed. Okay, we are going to discuss the number of methods which are useful to formation of carbanion. In that, one of the first method is, here is the removal of atom or group. First method is removal of atom or group. Suppose we consider this way, X is the any group, if Y is the species which is responsible to remove it, so Y remove the X, after that what happen, here is a formation of negative charge, XY combined together, so again we get the formation of carbanion. What is the example for that? The example is, suppose here we consider pH, pH, here is a Cl. Okay, so what happened, due to these three phenyl groups, this Cl here is twice Na, sodium metal is used. So sodium metal replaced this or displaced or remove the Cl with each by the sodium with the sodium. So what happened next? Here is the formation of carbanion plus here is another sodium is present to stabilize the, if negative charge is formed, there is some positive charge to stabilize there, plus one of the Na and Cl goes as a byproduct. So this way there is a formation of carbanion. So here is the removal of atom or group. Any group may be removed or any atom may be removed by the reagent, by the any species, and result is, if there is a negative charge left on the carbon, we call there is a formation of carbanion. It is a one of the method. Second example is, suppose here just we consider pH, pH and H. Okay, so what happen here again, if this H is acidic, this H is acidic, why? Because 3 phenyl groups are present. Phenyl groups will stabilize the carbanion due to resonance effect. So here it is acidic but very weak in nature. The protons are acidic but very weak in nature. So for that we need the strongest base NaNH2. Sodamide is the strongest base we can use here to remove the H. So after this there is a Na plus, NH2 minus, NH2 minus remove this H plus H, and there is a these two electrons are goes on the carbon, so their result is formation of carbanion. The result is formation of carbanion. So NaNH2 used in liquid ammonia as a solvent, the efficiency of base is increases in a NH3 because of NH2 is more strongest in nature. Okay, this way there is a formation of carbanion. Next one is we are going to discuss from alkene and alkyne. Second method is from alkene and alkyne. So you all familiar with this alkene, alkane and alkyne. Suppose I just write here, there is a alkene, then CH2 double bond CH2 is the alkene, then HC triple bond CH is the alkyne. So here again formation of carbanion, it depends on in which case there is a acidic nature of proton is present. So here also proton, suppose I just write here, here also proton, here also proton. There are three, not a proton, there is a hydrogens. Which is more protonic, which is more acidic, it depends on S character. So you all know alkane has sp3 hybridization, alkene has sp2 hybridization, alkyne has sp hybridization. And here you can clearly see, here is a S character. If you measure here, here S out of this total S character is 25%. Here S character is 33.3% and here S character is 50%. When S character increases, the S orbital is more close to the nucleus, and due to this the electronegativity is increases. Electronegativity of carbon is increases. So here as compared to sp3, sp2 and sp, here is a more S character. That's why this carbon has more electronegativity. More electronegativity. Due to this more electronegativity, there is a polarization between the CH bond. That means the acetylene means alkynes are easily lost this proton, easily lost the proton and formation of carbanion. That means if you compare the acidic strength, if you compare the acidic strength or acidic strength as measured as a pK value. So here the acidic pK value is 25, here is a 37 and here is a 52. So you already know acidic character measure as a pK value. Less the pK value, that means more will be the acidic character. So here less pK value, that means more acidic character of this H. This H is easily removed. This H is easily removed and formation of carbanion. Suppose any base is present here, it will abstract this proton and formation of HC triple bond C negative. Means again acetylene has or alkyne has tendency to make a carbanion as compared to alkene and alkyne. This is one of the reason. Okay. Next one is introduction of, third is introduction of inductive effect or electron withdrawing substituent. Electron withdrawing electron withdrawing substituent. Electron withdrawing substituent means the atom or group has the electronegative character, or atom or group has the withdrawing effect. Suppose here for that H, suppose here is a R R R, and say in second example suppose here is a F F F. Okay, so R is electron donating effect, donating group. So here fluorine are electronegatives, means fluorine has withdrawing effect. Fluorine, all fluorines has withdrawing effect, but here is the donating effect. So in that case, here electron donated to the carbon, carbon becomes more rich. So this polarization is not effective, but due to this withdrawing effect, the three fluorine atoms withdraw the electron from carbon, and carbon withdraw the electron from hydrogen. That means this hydrogen is more acidic. This hydrogen is more acidic in nature. That means here after minus H plus we getting this species. Okay, this negative charge is stabilized. This negative charge is stabilized. If you see here the flow of electron towards the fluorines, that means this negative, the density of these electrons will spread on these three fluorine atoms. That means here carbanion should be stabilized. Carbanion is stabilized. So one of the condition is required, the carbanion should be stabilized. It is formed, but after forming of carbanion, if it is stabilized or not, this is very important. So in which case carbanion is formed, in which case carbanion is not formed. If you compare the study, if here, if we see, if here carbanion is formed, so what happened, the electron flow towards the carbon, means three alkyl groups giving the electrons to the carbon, means this charge is not stabilized. So that's compared to these two examples, here formation of carbanion is more easily, more readily, because of stability, as well as there is the acidic character developed on the hydrogen due to presence of three fluorine atoms. We can take another example. Suppose we consider CF3 as a substituent, and here is the H. Again due to nine fluorine atoms. Okay, they are far from this center, but again they are close. So 9 fluorine atom, again CF3 group shows minus I effect. Due to this minus I effect, the electron flow of these bonded electrons flow towards the carbon. Again this hydrogen becomes acidic, and they can easily form carbanion. So introduction of electron withdrawing substituent also responsible for the formation of carbanion. This is another example. Third type of formation we are going to discuss is introduction of minus R effect. Suppose there are three examples. Okay, so cyanide, carbonyl and NO2 group. You all know cyanide, carbonyl and NO2 group has minus R effect. Which effect? Minus R effect. That means NO2, there is a positive charge, this delocalization is here. Due to this minus R effect, the alpha proton, all are the alpha carbons, the alpha hydrogens are acidic. Alpha hydrogens are acidic in nature. Due to this acidic in nature, base will abstract this proton. All three, on all three CH3 groups, the base will abstract the proton and formation of carbanion. So after loss of proton, what happened here? Here is a CH2 negative, C triple bond N. What happened here? Here is a CH2 negative, C double bond O. What happened here? CH2 negative, NO2. That means once we getting the proton, we getting the carbanion, the condition is it should be stabilized. It should be stabilized. That means here minus R effect groups easily stabilize the carbanion as compared to inductive, means minus I effect group. Minus I effect groups will stabilize the carbanion as compared to plus R effect. Means if we compare the formation of carbanion and stability of carbanion, plus R effect group destabilize the carbanion, while minus R or minus I effect groups will stabilize the carbanion. So this way you can form the carbanions in a number of reactions. Suppose here number of electron withdrawing groups are increases, again acidic nature is increases, That means for strength of formation of carbanion or ability of formation of carbanion also increases. Means suppose we compare, here is the NO2, or we compare suppose CH, and here how many 3 NO2 groups are here. So again strong withdrawing effect is available. Due to this, again the acidic nature of hydrogen will increases. That means as compared to this is readily from the carbanion because of number of electron withdrawing groups are increases. So this way we can form the carbanion. Last one is carbanion formed by the carbonyl compounds. Carbonyl compounds has unique ability to form the carbanion. So which carbonyl compounds? We have the number of carbonyl compounds. Aldehyde, suppose we consider ketone, suppose another example is ester, this way. So in that case how carbanion is formed? You all know the carbonyl carbon has which effect? Minus R effect. Carbonyl carbon has minus R effect. So minus R effect is present. Due to this the alpha hydrogens are acidic in nature. The alpha hydrogens are acidic in nature. Means if base is available here, suppose hydroxide ion is considered. So base has tendency to abstract the proton. Suppose I write here just OH minus will abstract this one, and formation of carbanion. Formation of carbanion. Same way here also formation of carbanion. Okay, means in all cases there is a formation of carbanion. In all cases there is a carbanion is stabilized. This way carbanion is stabilized. But if you compare in which case more stabilization, in which case there is a less stabilization, you can clearly see here. This carbon means stability of carbanion depends on deficiency of carbonyl carbon. How carbonyl carbon is deficient? If carbonyl carbon is more deficient, that means it has ability to stabilize the carbanion more effectively. So here there is a hydrogen do not shows any structural effect, but here is the alkyl shows plus I effect. Okay, here is the OR group shows plus R effect. Okay, so as compared to aldehyde, here is a some donating effect is present from other side, means this carbanion is more stabilized because here deficiency is more as compared to this one, because alkyl somewhat there is a fulfill the deficiency of carbonyl carbon. That's why this stabilization is less effective as compared to aldehyde. If you compare these two, here is a plus I, here is a plus R. Plus R resonance is more powerful, more effective as compared to inductive. Means as compared to inductive, resonance has more tendency to giving the electrons to the carbonyl carbon. Means this deficiency is fulfilled this by the OR group. Means as compared to ketone, ester, in ester case deficiency of carbonyl carbon is less due to plus R effect of OR group. Means the conclusion is here is a more stabilization because here is a plus I effect from other side, but here is a less stabilization because of from other side there is a OR group. Means here is a more stabilization if you giving the number order first, then second, and last one is the ester. Same thing for acid also, but in acid case the carbanion is difficult. If base is present, base abstract this one, not abstract this protons. Means only aldehyde, ketone and ester we compare the formation of carbanion, stability of carbanion. Stability of carbanion we will discuss in later case in detail how carbanions are stabilized. But I just clear the points in same point, formation as well as stabilization. Okay. So this way we can see here the formation of carbanions. In next point, stability or stabilization. So carbanion is stabilized, it depends on number of factors. So which factors are responsible? I already told you, first is the S character. First is the S character. Okay. Means those carbon has more S character which has tendency to stabilize the carbanion more effectively. Means as compared to alkane and alkyne, here this carbanion is more stabilized because here is the sp3, here is the sp2, here is the sp. So here 50% of s character, here 33.3%, here is a 25%, means in the last case there will be the more stability of carbanion because of due to मोर एस कॅरेक्टर. आता एस कॅरेक्टर जास्त होतं म्हणजे काय होतं की एस कॅरेक्टर जर जास्त असेल, एस ऑर्बिटल इज अ स्पेरिकल, इट इज मोर क्लोज टू द न्यूक्लियस, means here 50% electron density occupied in s orbital, it is more close to the nucleus, that means this nucleus has more electronegative effect. So the carbon, this carbon has more electronegative effect than this one, because here is only 33.3%, here is only 25%. So where is the more s character, this more s character has more electronegative effect and this will more stabilize the carbanion. Second is inductive effect. Second one is the inductive effect. Suppose we compare CH4, then we compare CF3, HCF3. Okay, after that we compare HCCF3. Okay, so what happened here? Here is the all our hydrogens. You can write this way. Here F, here is the F, here is the F. Okay, here is the L, CF3, CF3, CF3. Means we think about this one, protons. Means these are hydrogens. If they are behave as a proton or not depends on the other substituent. Here all are hydrogens, there is no any effect, so that's why here the acidic strength is very negligible if you compare. But here due to this minus I effect, 3 minus I effect, due to minus I effect of 3 fluorine atoms, the hydrogen becomes acidic. And here again 9 CF3 group, again powerful electron withdrawing effect, because each carbon has 3 fluorine atoms, means again here the minus I effect, but this minus I effect is powerful. So we can write this way, means in last case the this is more acidic character as compared to this one, as compared to this one. So when we convert these species into resulting carbanion, we getting, so here is a CH3 negative, here is a CF3 negative, and here is a C negative, thrice CF3 groups. So 3 CF3 groups will stabilize carbanion more effectively as compared to only 3 fluorine atoms. So here is a more stabilization as compared to this one. Here is a more stabilization as compared to this one. Okay, this is the example. Again, this is the another example. If we compare, what happen if there is a plus I effect is present. So for that I just taking example here, R CH3, R CH2, then R2 CH minus, then R3 C negative. Okay, so what happened? So here is a methyl. After it is coming from CH4, it is coming for RCH3, it is coming for R2CH. Okay, R2CH2, it is coming from R3CH. This carbanion, when it form, you can easily understand how they come from. I just write here, they are coming from, this one coming from CH4, it coming for CH2R, this one coming from R2, sorry, CH3, here it is coming from this way, and this one coming from R3CH. Okay, so in that case which is more stable, in that case which is more stable? So here CH3, you know the alkyl group has plus I effect, so here plus I effect, here double plus I effect, here triple plus I effect. So I already told you the electron donating effect destabilize the strength carbanion, stability of carbanion, and minus I effect increases the stability of carbanion. So if more plus I effect means more destabilization. So this will more stable, because of here due to higher or strong plus I effect, the negative charge will destabilize by the 3 alkyl groups. So here the order is like that. The order is like that. Means CH3 has more stability as compared to R3C negative. So it is all about the stability of carbanion. So point of discussion is minus I effect will stabilize the carbanion, plus I effect destabilize the carbanion. More plus I effect means more destabilization, more minus I effect means more stabilization. So this is your point. Second thing is resonance. Second thing is resonance effect. How resonance effect will stabilize the strength of carbanion we are going to discuss. So resonance effect means what? If the carbon having negative charge and here electron withdrawing group, this electron withdrawing group has minus R effect. So here this negative charge is delocalized by the resonance, means directly delocalization of the electrons, but in an inductive there is not a delocalization, there is a delocalization via sigma bond, but here delocalization via the pi bond, and this is more effective as compared to inductive. So in electron there are two electron withdrawing effects, minus I and minus R. So minus R is more powerful. So if two structures in a two compounds, in one compound there is a minus I, in a second compound there is a minus R, so in which case there is a more stabilization. So in resonance case there is a more stabilization because negative charge is readily delocalized. So this is the more stabilization as compared to inductive effect. Okay, so for that we are again taking same example which are already discussed in the formation of carbanium. Suppose here CH3C triple bond N. Second example CH3C double bond OR, whatever aldehyde or ketone whatever. Here CH3NO2. So here which has more effect? So carbonyl has more effect as compared to cyanide. NO2 has more minus R effect than carbonyl group, means NO2 has stronger minus R effect. Stronger minus R effect. That means the carbanion which is formed in all three cases here will be the most stabilization. So NO2 there is a positive charge, oxygen is there, so here is a more withdrawing effect as compared to this one, here is a more withdrawing effect as compared to this one because Cn and here is a CO, so oxygen is more electronegative than nitrogen, that's why carbonyl carbon has more withdrawing effect than cyanide. So this way, this is the first, here is the second, here is the third. So question asked like that, you have given the 3 or 4 carbanions, so choose the correct order of increasing order or decreasing order. So keep in mind, see, stability of carbanion depends on withdrawing effect, how withdrawing effect is stabilized or how withdrawing effect is powerful. So if 3 examples are given in which choose the correct order to be stabilization of carbanion. So first, second and third, because your examination is MCQ based, so prepare the study as point of view online point of MCQ pattern. So 3 examples are given to you, so choose the correct order of decreasing order or increasing order which is asked to you, so you clearly understand. Just keep in mind, more withdrawing effect more stabilize the carbanion, okay, more donating effect more destabilize the carbanion. So this way you can choose your order of stabilization. Last one is rearrangement reaction. Last one is not a rearrangement, what is the point, aromatization stabilization. So aromatization stabilization, what is the aromatization? Stabilization of negative charge due to aromatic character, due to aromatic skeleton is the aromatization or aromatic, or you can say aromatic stabilization. For that we taking here simple example. Here is a cyclopentadiene. It is a cyclopentadiene. So this is not aromatic compound. Okay, but it is the cyclopentadiene because these 4 carbons are sp2 carbon, but one of the carbon is sp3. Suppose due to this double bonds, if somewhat acidic character is developed and strongest base is used, any strongest base is used, strong base is used. So strong base will abstract this proton. After this abstraction, we getting there is a negative charge. We getting here negative charge. So is it the charge is stabilized? Here is the formation of carbanion. This is our carbanion. So carbanion should be stabilized is one of the condition, and yes, here this negative charge is in a delocalization, and after loss of this proton, it is a cyclopentadiene anion. It is a cyclopentadiene anion, and cyclopentadiene anion is aromatic in nature. It is in aromatic in nature because of here there is a delocalization, and this carbon is sp3. Again here is a sp3, but after delocalization here is a formation of double bond. Here is the formation of double bond. Again means there is a delocalization over on the all the 5 carbons, and all 5 carbons getting the double bond means here all carbons having sp2 hybridization due to this resonance stabilization, resonance delocalization means, and you know what is the condition of aromatic? The compound should be planar, compound should be conjugated, planar, conjugated, cyclic, and which is obey the Haeckel's rule. It is a 4n plus 2 pi electrons. So here if 4 into 1 plus 2 is equal to 6 pi electrons, and yes, here is a 6 pi electrons, not a 4 pi electrons, but before that here is only 4 pi electrons, but now here is a 6 pi electrons because all electrons in a delocalization. That means we consider here 6 pi electrons, and this species is a aromatic. This species is a aromatic. So this is a aromatic stabilization. Second example is given to you is, suppose toluene is given to you, CH3, toluene is given to you. Suppose this CH3 lost their proton and converted into CH2 negative. Carbanion is formed. Is it our carbanion? So is it carbanion stabilized? Yes, it is stabilized. Means aromatic ring stabilize the carbanion. Aromatic ring stabilize the carbanion, or aromatic ring stabilize the negative charge. So this way we can write here as a, so this way the negative charge is stabilized over on the ring, means it is called as aromatic stabilization. It is called as aromatic stabilization. This way we can complete the resonance. So we getting this, and we comes up to in a final structure. There is a, so in last, so back to the original structure. Okay, I just represented as double arrow because there is, between this there is one more structure is here, this state structure. Okay, but I here directly taking the final structure. So this is the aromatic stabilization of carbanion. So you should try to understand how aromatic ring will stabilize the negative charge which is adjacent to it. If the aromatic ring having the negative charge on adjacent carbon, the negative charge will stabilize. So in that case aromatic ring has minus R effect, withdrawing effect, because aromatic ring withdraw the electron from this carbon. So here minus R effect of aromatic ring will stabilize the negative charge. So this is all about the formation and stability of carbanion. Okay, in next point we're going to discuss the reactions involving in carbanion. So it is very important point, reactions of carbanion. Reactions of carbanion. So which are the reactions of carbanion? We're going to discuss in detail.